Okay, so a couple things. There's another math online homework thing that will be available at noon after today. Then there are 2 paper homeworks that will be available at noon. So you can either hand them to me Friday in class or Monday in class, or some of you may not show up to class, which is a shock, given that many of you are already not here. You can give them to the main office, and the assistant there will take them. They're due at noon on Monday. We're probably not going to get any recitations next week. I don't know if your TAs have canceled them yet, but I told them they have permission to cancel, and generally if you give people the option, you know what they choose. Right? So there you go. We are having class Monday at 11 o'clock, where I will give out the final exam questions in advance for anybody who shows up. Okay. That actually won't happen, but one of you probably believed that just now, which is sad. There's also no Easter bunny. But if 3 of you show up, I might actually do it, but we'll see. I have been known to reward the people when there's very low attendance. Just so you know. Okay. Anyway. Not a lot to do in today's class, so we'll see what we can get done. Look at this. This isn't washing the board. Come on. That's just sort of schmutzing chalk around. Wow. So disappointing. Anyway, hi. So we did all that adding up the rectangle stuff. Isn't that fun? That's sarcastic, but it's not fun. I understand it's very tedious, which is why we invented integration. And if you don't have to do these approximations. And as I said last class, there are functions where there is no way to do the integral. For example, you can take the derivative of e to the x squared, pretty easy. You cannot integrate over the reals e to the x squared. You can integrate e to the x, you can't do e to the x squared. Because there's no function whose derivative is e to the x squared. So there's no real function, okay, as far as you're concerned. The good news is very few of the functions you will deal with cannot be integrated. Almost all of them can, so that whole approximation thing, it's not that important. It's more important to understand it conceptually so you know what's going on. So now let's just do the integrals for real. So remember, and I did this the other day, but I'll do it again. So if you have some zone, you want to find that area from A to B, you could do the rectangle thing. That's really annoying. So what you do instead is you integrate the function from A to B. So you put those what are called limits of integration, the limits of integration. What this means is you do the antiderivative of B minus the antiderivative of A. So that is the antiderivative of x. Okay? And there's no plus c. This is called a definite integral. Remember, the indefinite integral is called indefinite because you have a plus c term. You don't know what the actual function is. You can find it if we give you an initial value. But here, what would happen is the c's would cancel. That's why you don't need it. So for example, remember we did the approximation of the integral of x squared plus 3 from 0 to 4. Now we can find the actual value from 0 to 4. So what's the antiderivative of x squared? Yep, x to the third over 3. What's the antiderivative of 3? 3x, gotcha, good. You draw this little line, that just sort of stands for what the limits are. When you plug in the top number, you plug in the bottom number, and you subtract. So this was 64 thirds plus 27 minus 0. So that's 48 and the third, and I believe we guessed that it was 48. Yes?
Why did it plug into?
Oh, that should be a 4. I'm sorry. Good catch. And actually, right, I think it was 32 that this came out when we were guessing. And this comes out 32 and a third. Okay? Remember, we did the approximation, and underneath we got 24, and above we got 48, and we said, well, maybe it's 32, so 32 and a third. Okay? And that's exact. And again, you get to that integral by doing the rectangles, doing an infinite number of infinitesimally thin rectangles. And so when you add up all of those infinitesimally thin rectangles, you get this. The dx is what was the delta x. So that was the width of each rectangle. This is the height. So it's each height times each width. And you add them all up from 0 to 4. So that the giant S stands for sum. And that's integration. Okay, so if we said, by the way, you couldn't need a calculator for the homework. Feel free to use a calculator in the homework. Feel free to use a calculator on anything but the exam. All right, let's see if you can do that. All right, that's long enough. So all this says is the integral from 1 to 2, 6x squared plus 8x minus 5 dx. Okay, so what is 6x squared? The adject derivative is 6x cubed over 3. Plus 8x squared over 2 minus 5x. Let's simplify that. That's 2x cubed plus 4x squared minus 5x. And we're going to evaluate that from 1 to 2. Okay? So you want to simplify these things as much as possible before you plug in. All right, so plug in 2, and you get 2 times 2 cubed plus 4 times 2 squared minus 5 times 2 minus 2 times 1 cubed plus 4 times 1 squared minus 5 times 1. So let's see, that's 16 plus 16 minus 10 minus 2 plus 4 minus 5, which is 32 minus 10 is 22, minus 1, which is 21. Okay? Managed to get 21? Most of you? Good. So, you know, when you say the land of partial credit, well, you get partial credit for getting to here. Then you get more partial credit for getting to here. And you get that last bit of credit for getting to there. Okay, so sort of multiple steps to a problem like this. All right, let's have you practice a couple more of these. Okay, how about all right. So let's integrate this. So what's the integral of e to the x? E to the x. From 0 to 2. That's e to the 2 minus e to the 0. Which is e squared minus 1. That's it. You don't have to figure out what e squared is. Okay? E squared should be about 8. A little less than 8. 7.8, something like that. E cubed is very close to 20. But as I said, you're never going to be in a situation where you're going to have to use e. Okay, you can use a calculator. So to get an e, you figure out what e is. All right, this one is the log of the absolute value of x from 2 to 5. So it's log 5 minus log 2, which again, just leave it alone. You can make that log of 5 halves if you want it, but it's not necessary. Suppose I gave you integral from -2 to -5 of 1 over x. Remember, it's absolute value. Okay? So this would be the log of the absolute value of x from -2 to -5. So again, it would be log 5 minus log 2. Okay? Yes?
Can you leave it like with the absolute value instead of 5 and 0?
I mean, can you leave absolute value of 5? Sure. It's not wrong. Yeah. You should know that the absolute value of 5 is 5, but you
No, I know.
can leave the bars there if you want. I understand the way people work on exams and stuff, so. And they're nervous that maybe it's not 5 this time, so just in case they leave the absolute values, it's fine. We're gonna have a shorter class today, and that makes you sad. But there's a little stuff more that we have to do. All right. Suppose we are told that the marginal profit is p prime of x is the square root of x minus 6. And this is for the sale of x seats on our jet. Where x is in hundreds of dollars. Okay? So 5x, so when x is 5, it means 500, not 5. Okay? I'm going to change the number. Okay, so you can figure that out. And that's sort of a real world example. X is in seats, P is in hundreds of dollars. Let's think about what this graph looks like. Square root of x minus 6. Let's do a better graph than that. Square root of x minus 6 looks something like that. Okay? Where this is 36. So this profit is a negative number. Remember, we're doing the area between the curve and the x-axis. So you're losing money, certainly up to 36. But beyond 36, you're still losing money until this area equals this area. And then at some magic point, you'll break even, and then beyond that, you'll make money. So you can guess what question C is going to be. Okay, so part A. My profit is missing a T, it says profit. Okay, so I'm going to find integral from 0 to 60, square root of x, which is x to the half, minus 6 dx. That is x to the 3 halves over 3 halves, minus 6x. 0 to 60. 64, sorry. Okay. Which is 2/3 of 64 to the 3 halves minus 6 times 64. Minus, when you plug in 0, both of these terms are 0. So let's see, that's 1024 over 3 minus 384. That is a negative number. That is negative 128 over 3. Is that right? Negative $42.66, and then times 100. So So you're losing about 4,000 bucks. You guys get that number? Well, one person's saying yes. Anybody else? So I'm doing it in my head. It's possible I'm messing it up. You know, I'm old. Those of you who agreed with the I'm old sentence, you might as well just leave class now. You're not going to pass. It's over. Okay. What if I increase from 64 to 100 seats? Well, you could do two ways. You could go from 0 to 100, right? And then the 0 to 64 you could subtract, or you could just do from 64 to 100. So if we're going to do x, we have 2/3 x to the 3/2 minus 6x from 64 to 100. And then are we making money at 100? Well, let's see. That is 2 times 100 to the 3/2 over 3 minus 600 minus that number, because that's what you get when you plug in 64. So 100 to the 3/2 is 1,000. So 2,000 over 3 minus 600. See, that comes out around 66 and a third. Okay? Plus, you're making more money because you got minus this. So I think you get 109 and a third. Is that right? Anybody else get 109 and a third? 328 thirds? So you're making money. The question is, where's the break-even point? What number breaks even? Did I say how I did the second one? I just did it again from 64 to 100. So we want to know, what's the number going from 0 to k of x to the 1/2 minus 6 dx that's going to equal 0?
Is that part C?
Yeah. So part C is, what's the break-even number? Any of you guys remember the 7 bus? Any of you here last year when we had the 7 bus run? So the bus from the SAC to New York City. We ran maybe 5 times a day each way. It was $7 each way if you reserved it in advance. That's pretty good.
Yeah.
So I sat on the bus. You know, sometimes I got on that bus at 11 o'clock and there were maybe a total of 15 people took the bus to the city. So 7 times 15 is $105. So there's no way they're breaking even at $105. That's how much they spend on gas and the bus driver, easily, not counting the bus. So I sat there and I said to myself, well, maybe different rides, maybe it's full if you take the bus at 5 o'clock. No, there were very few times where that bus was really full, which is too bad, because the people who took it really liked the idea of $7 from the SAC. Took you to Grand Central Station, basically. So it turned out that they were making money, because they ran enough of these, but the company itself was losing money, so that's why they stopped. But if any of you want to get into the entrepreneurial business, I recommend a shuttle bus that runs from the SAC to New York City. There's obviously high demand for that. Making a stop in Queens on the way in, you could probably charge $10 easily and fill that bus at certain times a day. That's what I would do. You know, there's what they call the Chinatown bus. It runs from Chinatown to Boston. There's one that runs to Washington, D.C. Charges nothing. I think $20. They hack that bus. So break-even number is really important. Okay, you go to a restaurant. There was these restaurants in Manhattan I would go into, and you go in and there's nobody there. You say to yourself, well, maybe it's just a bad day. So you go to a different day. No one there. You know, no one. Like 3 people plus staff and food. You say to yourself, this restaurant will not survive. Okay, you can sit there and you can think of how many people you need to do to survive, because this is a real business calculation. So there's a sushi place I like to go to around here. So I say, okay, what do I think is their rent, air conditioning, food, how many people are working here, blah, blah, blah. And I said to myself, probably $30,000 a month. Sounds like a big number, but there's 30 days in a month, so that's $1,000 a day. That's to break even. So they need to make $1,000 a day. If each person is spending $20, which they're not, that means you need to get 50 people every day. Okay? That's just to break even. So you said, we really need to get 100 people every day, or why are you bothering to have your sushi restaurant? This isn't counting the fact that you can steal cash and things like that. You can't make that much money if you're crooked. So you sit there, you go for 3 or 4 times and say, well, 4 people at lunch, 20 people at dinner, that doesn't equal 100. How many takeouts are they doing? And you pretty quickly say to yourself, well, this restaurant won't be here a year from now. And sure enough, a year from now, they're gone. Okay? So if you guys want to get into business, that's the kind of stuff you want to do. That's why break-even number is so important. See if they're making it. Okay, we're going to open this new place. It's opening any day now across from the train station, the Calzone place. You guys seen the signs for it?
Where that dog grooming place was?
Well, that's going to be a tea place. The dog grooming place is going to be Kung Fu Tea. And next to it, right, is going to be, next to 7-Eleven, there's going to be a calzone. It's going to be open late, so you go to the bench and then go get your food. Apparently the food tastes really good. So you go in there and you say to yourself, are they going to make it? Go in and look at all of these various shops and ask yourself, how much do I think they need to make? And are they breaking even? That's real business stuff, okay? And you're not going to use calculus to figure that out. You can just make a rough guess. You can ask if you get the owners in a good mood. He or she will tell you what the rent is and the electric bill. The air conditioning is expensive. You got your employees, taxes. But if you don't make any money, you don't pay any taxes. Usually you can avoid taxes for a couple of years, but at some point you have to pay them. When you're losing money, you don't pay taxes. So in the beginning, the IRS sort of gives you a little time to get your restaurant going. You got the cost of all the supplies. And then you say to yourself, all right, how many customers do I need to get in here every day? So then the reverse, you look at the Starbucks bookstore, that place is a gold mine. Think of how much money there, think how many people are going through that Starbucks every day. I mean, I have trouble calculating, but they're making thousands of dollars a day. So that's what you want. They want to have that line out the door. When they say, sorry, we're so crowded, they're not sorry they're crowded. They're thrilled they're crowded. They're just sorry that you're waiting. So anyway, these are the kind of calculations you want to do. So how would we do the break even? So if we figure out the formula, we say, well, let's see, this is 2/3 x to the 3/2 minus 6x from 0 to k. Pick any letter you want. So since the 0 part doesn't matter, it's 2/3 of k to the 3/2 minus 6k has to come out 0. So remember what k to the 3/2 is. That's k times k to the 1/2. So you can factor out k. And you're left with 2/3 of k 1/2 minus 6 equals 0. So at 0, in other words, when k is 0, we're certainly going to get 0. Duh. Okay, we're not integrating anything. Or this. So we just solve that. So that is 2/3 times the square root of k has to equal 6. So the square root of k has to equal, is that 9? Yeah. So k equals 81. So if you get 81 seats, you make 0 money for the flight. And then you start to make money. So you need at least 81 seats. Now airlines is very complex because they're constantly changing the seat prices and who sits where and all that stuff. They spend a lot of money. Major cost for airlines is jet fuels and maintenance. You have to keep the plane from crashing, and you have to fill it with fuel. Fuel's very expensive. That's why they pack you in. They came up with this clever idea about 15 years ago. A lot of businesses use September 11th as an excuse to take money from you. So one of the things they did was they said, oh wow, we're going to have to check all these bags now. They're very cynical, remember? So they said, well, we're going to charge you a fee to put your bags on planes. So you guys are used to that. There didn't used to be a fee. You just took as many bags as you want, up to some reasonable limit. If you took 8 bags, they charged you. Now they just charge you for everything. If someone would say, wow, we won't charge you. Trust me, they're building it into the price. This has been, airlines used to lose lots of money. This has been where they start to make money. They just make money on bag fees. Or they charge you for peanuts. They discover people couldn't stand the food anyway, so they might as well just give you a bag of peanuts. If you want a second bag of peanuts, they charge you $1. Okay? And, you know, you laugh, but you're going to come out, you guys are going to get jobs in the business world. Some of you are going to have these kinds of jobs. Like, what should we charge for Sprite on the next airline flight to make more money? And you'll be the person who says, well, if we raise it from $1.10 to $1.20, we make this many millions more dollars this year. So, you know, these are real world problems. And often, you don't really have an equation that makes any sense. But if you can have an equation, this is the way you figure it out. Okay? Hope that was entertaining. All right, well, I got through everything today with about 8 minutes to spare, so we'll see you on Friday. For those of you who are already on vacation,